Hello, everyone. Can somebody give us a thumbs up that you can hear us? Yay, okay, awesome. Thank you so much. Thanks for joining us today, and apologies for joining a little later. We were, the phone apparently didn't like the number 6, so that always is fun when that happens. So I am excited today because we have a really great presentation about OpenCensus. Census has definitely been the thing that I think was the most stumpable whenever we did our community meetings. People would always ask questions about census, and so I'm excited that we've got somebody here to give you a demo and an update on using it with gRPC. Before we jump into that, does anybody have any announcements or anything that they would like to share with the community? Say hi or anything like that?
Maybe I'll take a chance to introduce myself, since this is the first meeting I attend. Is that okay?
Hi.
Hello, I'm Alejandro, and I work for GitLab. I believe Andrew was on the last meeting, so I'm working on the same project as him, which we're building with gRPC. Thank you for having me.
Welcome.
Yeah, great to have you. Yeah. All right, anybody else? Okay, well, in lieu of that, Yana, you want to take it over and tell us all about the cool censusness?
Yeah, sure. I can take over. Thanks. So I'm JBD. I'm Yana. I work on the census team. I actually wanted to give a little bit of demo, but I will first begin with some of the concepts we have. So it's kind of going to be more of a presentation. So let me share my screen. I hope that you can see it. Can you see the screen right now? Okay.
Yes.
So let me introduce myself first. I work at Google on the OpenCensus team. We are a team mainly focused on instrumenting our services. I lead the OpenCensus Go part. We have a language-based team. We have multiple sub-teams under OpenCensus. And generally, I would just want to, give you a little bit of observability and, observability, especially in distributed systems and how our gRPC integrations. So I think many people have heard about observability, but there are a few different definitions. So I want to clarify my own definition, or our definition first. We call observability this holistic approach to be able to, observe a system for some for reliability, performance, deployability, and so on. We look at different signals in order to achieve that. Metric collection, distributed tracing, profiling, login are a few of those. So I'm going to just give you a brief overview of the motivation, some of the best practices, and some of the concepts we came up in the past years to make our production systems reliable, and explain you how OpenCensus came around. So I said signals, who wants to have metrics more easily from gRPC services and clients, or be able to trace their RPCs and upload to the favorite choice of trace and backend, or collect some profiles from production services in a way that so you can pinpoint some of the hot spots in the scope of an RPC. So before getting there, OpenCensus is actually providing is a foundation layer that gives you all these signals from services and allow you to upload the instrumentation data to your choice of backend. But before getting there, I just want to explain you some of the core concepts behind OpenCensus and why we came up with those concepts. So to give you a little bit background, we work for a dominantly distributed systems company, and one of the common architectural patterns we use is the microservices architecture. At any time there are lots of teams working on different microservices, and each team is sometimes responsible for a bunch of different services. So being able to observe our systems is a fundamental reasons why we became reliable, fast, and user friendly. And in order to be able to observe our systems, we had to instrument them, and we invented some collection methodologies, export formats, like new philosophies in this area. Our instrumentation stack is cares about efficiency and the overhead of the collection. So observability is a part of our engineering culture, but we actually enabled it by making it easy and lower overhead. And before digging more into the distributed systems observability, there's one thing I want to explain because it's a little bit different. Observability is different in distributed systems from monolithic systems because of one particular reason. So this architectural diagram is pretty much common at every, for every product at microservices companies. We usually have a, user-facing, very business logic-driven front-end server. It depends on various other services. Authentication, billing, and reporting are those examples there. And at some point, they will all, depend on some database layer and some low-end storage layer and so on. In this case, you can see the data store, our non-SQL database layer, becoming a, core dependency. So it's expected that at microservices companies, that like organizations, that some part of some services are becoming more of a common dependency. It's hard for the teams who are building and maintaining these core dependencies, gather meaningful signals. It's just so hard for them to understand the root cause of the problem, especially if it's triggered by their users. So in this case, both data store and blob storage teams will see fluctuations in their dashboards, but we'll have harder time to understand what is going on or where the problems are originated at. So it's also I focus a lot of about the case when things are going wrong, but it's not only when things are going wrong. Infrastructure teams often want to have the right answers in order to be able to just say that all of their systems are green, and they usually want to have some answers to this type of questions. Hey, are we meeting the SLO with this team, with the high level teams dependent on us? Are we providing the service that we promised to serve? Or they want to understand what is the impact of this high level other service on our service, and what happens if this high level service grows 10% overnight. Is our deployment going to be able to handle that scale? If not, what are our next steps, and so on. So we this is the reason why we want to be able to break down our signals in different various ways, especially at the low ends, because it's becoming more complicated to ask these questions. And we use dimensions in order to achieve that. We call, it's just, these different ways of actually asking questions. With dimensions, you can query the collected data in ways that help you to answer some of the earlier questions with. You can query things like give me the this blob storage request latency distribution for RPCs originated at analytics, or the very high level product, or give me the traces and reports that contains this specific RPC method, or give me the CPU profile for the RPCs started at analytics. So you can tell, for example, your compression, you can gather CPU profiles from your compression library, and you can actually query it in a way that only give me the CPU samples collected if the original RPC was coming from this particular product. So it's great that that like we can query this data, but the question is how we actually collect the signals, so it's it's queryable this way. We record all the instrumentation data with various key value pairs. We call these key value pairs tags. And then, the backend, for example, a metric collection backend like Prometheus can filter the collected data by tags. So there's one problem here, though. Like, if the solution is that easy, just collecting data with key value pairs, the problem actually here is, in the microservices architecture, you actually have no tight coupling between different services, right? So how can the database layer know about all these high-level dimensions that other teams might be interested in? This is where we get some help from the world of context propagation. So the tags, all these key value pairs and dimensions, are actually not in the low-level services. They are produced at the high-level services, and they are being passed all across the stack as a part of the RPC. So in this case, you see that like from all the way up to the bottom, the RPCs are being tagged. So the blob search at the low level doesn't have to know anything about these dimensions and what the high level other teams want to see from the data collected from blob storage. But blob storage just records all the data with the incoming tags. So in the end, you can go to the backend and like be able to query the data that way. So to summarize, we have this like culture of producing tags at the high level services, depending on the specific requirements of the teams, and we propagate those tags all across the RPCs. And then each component in the system can, record metrics, traces, and so on with these tags. As I mentioned in the beginning, we say observability is a holistic approach. Each type is, useful to answer different questions. For example, distributed traces cannot tell you anything about your CPU hotspots, or CPU samples cannot tell about the overall latency, the end-to-end latency problems. So we collect various signals to examine the problem and see the problem from different perspectives. And it became very clear, I think, very easily that it's very hard for developers to think about all these dimensions, signal types, build highly efficient instrumentation libraries, and instrument each layer they depend on. And that's why we decided to build a common framework, and decided to open source it and make it vendor agnostic so anybody can use it against any provider. I personally am working on the Go part, so I will keep the rest of the presentation more Go focused. So we've been working on OpenCensus for a long time, but finally we announced it yesterday. OpenCensus is this holistic instrumentation framework, the open source version of Google's Census project, but we actually are rethinking about pretty much everything from scratch and rewriting the entire library. It's not just we are open sourcing the existing one, it's entirely a new rewrite. And the main reason we are open sourcing this is we want to fill that missing building block in the open source world. We want libraries, frameworks, all sorts of infrastructure projects to be able to instrument without having to reinvent this concept. And if you're you are working for an organization, you can adopt these solutions we have already built or use it as a reference. So OpenCensus provides a single set of libraries. We currently have tags. Tags is this dimension propagation layer, metrics, traces, and we will support more signals in the future. We have language support for Go, Java, C#, C++, sorry, Python, PHP, JavaScript, C#, and Erlang are coming next. Our libraries are vendor agnostic and can upload data to any backend. So we support currently Prometheus, Zipkin, Stackdriver. I'm working on the Jaeger support for Go. Some vendors are also working on supporting OpenCensus. So we are expecting them to start publishing their own exporters for OpenCensus. We provide out-of-the-box integration, such as gRPC, and for Go, for example, the net HTTP package. We also, our libraries provide introspection, which is very interesting because we can provide you a tiny dashboard to report the usage from a single process. So without you having to really rely on an external service, you can see what is going on in a single process. It's very useful when you know there's a problem with some specific process, or if you want to use it during development time. So speaking of the framework integrations, I'm here for the gRPC integration to show you just a bit. Also at Google, we are considering about using the same framework internally, the new OpenCensus framework internally. This is how you import the plugin, the integration for gRPC for Go, and you just pass a stats handler to the gRPC clients and servers when you're initializing them. And in this case, we are looking at a server. So in the handler, what you can do is to extend the tags coming from the incoming context. In this case, I'm inserting hello as the originator service, and inserting the user ID. And then it will be possible for all of the collected data to be broken down by user ID and originator. This is how we record values. This is the metrics library. We have a measure total hello that represents the number of times we said hello. The stats record is going to save save one with the tags in the current incoming context. So you will be able to tell the number of hellos, broken down by the service name or by specific user. This is how it looks like in the dashboards. So you can break the data by the dimensions we have collected. In this case, each color is representing a different originator service. Baby blue is the number of hellos from the authentication service here, and the purple is representing something, and the other two dimensions originators are represented by green and dark blue. And gRPC plugin automatically creates spans for the incoming and outgoing RPCs, but you can also use our trace package to add custom spans. So here I'm creating a custom child span and finishing it. You can create as much as you want, and you can annotate them. You can set attributes on them. You can also, keep propagating the context. By using the context object, you can just create more children tracing the same trace. And this is an example of the traces collected by in the lifetime of this RPC. You can see all this internal RPCs made in order to satisfy this RPC. OpenCensus also have some support for pprof. You can use the tag package for Go, and if you collect CPU samples, it will collect the CPU samples with the tags inside the incoming context, so you can see the hotspots from specific requests. For example, this is a gRPC server I profiled with OpenCensus. You can see the runtime concat string spent 9.43 seconds for RPCs coming from authentication server, and 3.20 for the RPCs coming from the analytics server. To summarize, we have this holistic approach. We use multiple signals. We allow tags allow us to break the data by dimensions. So each team can produce the tags dimensions they're interested in, and they can pass it to the low-level other services they depend on by tag propagation. We instrument our core developer frameworks in service meshes and load balancers as well, so users can automatically get some sort of instrumentation out of the box. but they can use the same libraries to add fine-grained details, just like the case I did in the gRPC server handler example, by creating custom spans and so on. Our instrumentation layer is optimized to be very low overhead and low cost, so it makes it easier for libraries and frameworks to instrument without thinking about the cost of instrumentation that much. And once you adopt these concepts and put them in place, it gives you quite a solid foundation layer. OpenCensus is already available. It's vendor agnostic. We already support Prometheus, Zipkin, and Stackdriver. More exporters are coming very soon. We're currently focused more on framework integrations and writing more exporters. So I highly encourage you to take a look and give us some feedback and contribute. Thank you so much. More details is on opencensus.io. You can check it out, and you can take a look at the language-specific examples and docs. So I may have questions if you have any questions.
Yeah, one quick question for the presentation also. For example, in our service, we already implemented our gRPC service using the Prometheus middleware. Is there any advantage that we migrate to OpenCensus since we already have that?
If you're looking for portability, maybe you would like to switch. And we're now providing some out-of-the-box instrumentation if you use the stats handler. So you don't want to maintain that layer, for example. You can just reuse the existing measures and already provided by the OpenCensus integration. It's really up to you and your portability, and we suggest OpenCensus also people who are publishing code outside of their organizations. If you would like to provide some utilities and want to have some portable non-vendor specific solution to instrument, OpenCensus is a better approach than having Prometheus. But otherwise, I think Prometheus, if you're using internally, if the code is internal, I think Prometheus would be good enough.
Okay, thank you.
Any other questions? One of the other things is I think in order to, if you're dependent on OpenCensus, it gives you tag propagation very easily. And then, you don't have to even use OpenCensus. You can use those tags elsewhere, even if you're dependent on your custom instrumentation layer.
Awesome. Well, thanks, Jana, for presenting today.
Yeah, thank you.
If anyone else has questions that come up, especially as you get started, is there a mailing list or anything for OpenCensus yet?
Yeah, OpenCensus has a mailing list. I can add it to the meeting notes. We also have a gRPC demo, which contains how you export to Prometheus and how you export to different backends and so on. I'm also going to add a link to that. You can go through and see.
Great, thank you.
I actually have a question. So from a standardization perspective, I know there's a lot of standardization efforts and so on going around this. Could you speak a little bit more about that and how OpenCensus will sort of?
OpenCensus is involved in 2 standardization efforts. The first one is initiated by Prometheus team, Prometheus folks. They would like to standardize the exposition format. And it's kind of also, standardizing the data format. And we are involved in that. Currently, our data model is entirely matching, and we're trying to make sure that like we are meeting. If that standard is happening, we would like to implement that standard. There's another standardization format around traces, especially around trace context as the initial step, because all these backends propagate trace IDs differently, and libraries and the entire ecosystem cannot, since they cannot support vendor specific ways, propagation ways. Our libraries are not very aware of trace IDs and so on. We end up dropping things because we don't want to put vendor specific code in our libraries and so on. So we are standardizing how we propagate trace IDs in HTTP and beyond. That's also that's initiated by my team, and there are a lot of like different tracing backend projects and other vendors involved in that. So I can say that there are two very big standardization efforts going on.
Okay, thank you.
Yeah, no problem.
Anything else? Cool. Well, thank you again, Yana.
Thank you so much. Yeah, thanks.
Thank you.
So from everybody else in the community, any general questions you've got for the team or anything you want to share? Nobody wants to try to stump the team today? You can get a sweet hoodie. You can't stump each other though. No fair.
Thinking I can do that.
Hi there. My name is Nicholas DiPiazza. I'm new here.
Well, welcome.
Yep, we are working on a project, commercial source that uses gRPC, and I'm just kind of joining to get my head around some things. But if no one has anything, I would fire up with a general question on usability.
Go for it.
Wondering, we have the situation where we have a server that uses gRPC bidirectional persistent HTTP2 connections. And there's the option of, well, we could either start them all up initially and have them kind of always running, or we can have them, kind of fire up dynamically. And we're thinking of siding with just open up, however, say 20 connections, that the maximum amount we probably need, and just leaving them open. And on production servers, is this the kind of thing you do typically, or what is, is there going to be some hidden cost of this that's not going to show itself until we have some client using it in production? Not sure if that was clear, or if I have my volume is good. Or
So, no, we hear you. I guess I'm not really on the camera, but I'm right in front of the camera. My camera's right in front of me. Oh, hello, everyone.
And you got the shirt on and everything.
Yeah. This is what you can get online.
That's pretty cool.
Yeah, stressing for the occasion. So I guess I should just real quick ask, which languages are y'all working in?
Java.
This doesn't change too much to me. Okay, good. I'm even better. So whenever you create a channel, it does not connect immediately. So you're free to go ahead and create those channels initially and then just let them sit, and they will connect whenever you need them. There is the channel state API that you can use to ask it to connect for you. The thing is that is sort of a little bit of a one-shot. So you say get state on the managed channel. You say please connect. But you will want to end up watching it such that if it ends up going down again, you end up connecting again. That would be the sort of approach if you want to guarantee that you have lower latency for whenever you're ready to do an RPC. There might be a couple of other things that you want to be aware of, such as idle timeout, which right now we do not have a default for, but the channel is able to go to sleep by itself if there is no no actions happening on it. But as far as the basic question of, is it fine to sort of force these connections to be on just all the time? That's fine. You should sort of, be careful not to do it all over the place and make sure it's actually gaining you something. But whenever you're caring about the latency or wanting to make sure that these are actually going to work whenever you need them, that's fine. Also, in your case, you sort of know that it's going to be a fixed number. It's not just going to grow without bounds. And so those are the sorts of things that I would hope to see if you're going to do that. And that's totally done.
So typically, multiple servers are going to be involved here. Do you see potentially like network topology type issues that I might encounter if I just leave them on? Meaning that I'm actually connecting and connected, like having a bidirectional stream that's open and ready to go right on startup. Is network, some of these machines can sometimes have network issues. I'm worried a little bit about
right. Right, so sorry, because you were doing the BiDi stream, you did mention that earlier, I forgot about it. Because you're doing the BiDi stream, you don't actually need the connectivity state API. You'll just have the channel, you'll create the BiDi stream just initially, and anytime it goes down, you'll create it again. And that should be a little bit easier. The main thing that you might want to enable is keep alive. That will do periodic pings on the connection. Do be careful to not bump that too high of a value because it's very hard to diagnose load caused by keep alive. And that can be on the network or CPU or some other things like that. But whenever keep alive is on, gRPC will be sending pings occasionally to check the connection and notice if it's bad. And that you can enable on both server side and client side. And so for any long-lived, anytime you're doing long-lived RPCs, it doesn't even have to be BiDi, although that's the most common case of having long-lived RPC. It's good to enable keep alive.
Okay, cool. And
I sort of hope one day maybe enable that by default.
You had one thing you said to watch out for on keep alive, but I didn't catch it. I was too busy taking notes on the other stuff you were saying.
Oh, sorry. Oh, are you the squirrel?
It's probably Jay.
I was saying try not to be too aggressive on the keep alive setting because it is very hard to diagnose load caused by keep alive.
Got it.
Because it's mostly invisible. And so try to be conservative, as conservative as you can, while still getting some of the benefits.
Thank you very much.
I hope you don't have to keep the camera on you directly anymore. Does anyone else have any questions or anything you want to share? Anyone else we should put the spotlight on? All right. If no, then we can wrap it up for today. Thanks everybody for joining. And we have the recording, so we'll share that on the YouTube channel. And do check out the meeting notes, or we'll get the census mailing list and a link to the gRPC demo in there as well, so you can jump in and play around with that. And then we will meet again in a couple of weeks.
Thank you.
Thanks, everyone.
Thank you.
Thank you.